Hey, how's it going, guys? Today I wanted to do a video on something a little bit different, just a little bit, and that's gonna be this game controller. Wait, this background, this aesthetic, it's not working. I need something a little bit brighter. Give me a second. Okay, that's a lot better. You can actually see what's going on now. So yeah, this is my leverless fighting game controller. This is a hand-wired build, and some of these parts, mainly this case, were purchased through websites that have their own solutions for this kind of stuff. But I wanted to try my hand at hand wiring, so that's what we're looking at here. Before getting too into things, I do want to put a parts list up over here somewhere, of what parts are necessary for this, and a parts list over here, up here somewhere, hopefully, of what parts I personally used for this build, because some of these parts add on a lot of cost but are absolutely unnecessary. I just did it for either aesthetic purposes or simplicity purposes, or a combination of the two, really. But yeah, anyways, let's get this opened up and have a look at what's going on inside. So this is what's going on the inside. It is a bit of a mess, but don't mind it too much. We'll get into things here. If you're someone who's watched me previously for keyboard stuff, you may recognize these as keyboard switches. These are Kale Chalk V1s in this particular situation, the Pro Reds. I think they're a nice balance of weight. I do have a friend that has the pinks, which are extremely light, which like they're nice, but I feel like they're a bit too light for my playstyle, I guess. At the heart of it, though, we do have an RP2040. This is an RP2040 0. In particular, there is this little bump on right here, but this is all that's needed. And basically, there's this website called GP2040, which I believe is Gamepad 2040. Don't quote me on that. I'm not too into that scene or anything like that, unfortunately. But they provide a firmware where each pin here, I'll call it a pin for simplicity's sake, is assigned to one button. So it makes wiring this up super easy, where in keyboards you have things set up into rows and columns, which can be a little bit more complicated. And this is a pre-done firmware, right? It's already done for you. You just need to flash it and wire things up accordingly based on this pinout diagram that they provide. That said, though, you don't need to stick with the mapping they provide. You can reprogram it. They do offer a web tool for that, which is really handy. I actually really like how they took care of that. But that all aside, if you want to dig more into it, I'd suggest visiting their website. But let's talk about what's going on in here. So over here, I do have some micro tactile switches. These are 6 by 6 by 9 millimeters, I believe. And I had to go with quite tall ones because these don't sit flush. You can kind of see it over here, that they don't sit flush inside. And the reason being for that is that these are meant for these buttons that I use for the microcontroller. And there are surface mounted buttons that these push down on the original PCB for the Snackbox Micro, which is what this case is. I really wanted to get this case because it's translucent pink. I think it's beautiful. But because of that, they didn't sit flush. And what I could do is bust out a Dremel or something and sand it down smooth. But that would, I think, take away from some of the translucence, is that a word? In this area, which kind of wouldn't like. So I ended up hot gluing these in so I could actually get to them and solder them without them shifting around a lot. Now, in hindsight, I would have liked to apply some kind of overlay here before putting the buttons in. because doing so beforehand would have been a lot easier than afterwards. I've tried doing it afterwards because you can see these big globs of hot glue that just don't look very nice. But these buttons do function, so can't be too mad. These are your tack switches that would be used for like start, select, R3, L3, those kind of buttons. Buttons that aren't commonly used in fighting games, I'll say. For these buttons, these little buttons, again, are normally meant for these holes. I did have to drill these out just a tiny bit to get these tack switches to fit in and drill holes for these. And what these do is the RP2040 has, I believe, a boot and reset button on the actual microcontroller, which is super handy. And so in order to flash a firmware to this, you want to hold both of these while you're plugging in the device. But with these buttons facing up, right, unless if I have these holes here, I won't be able to access them. So if the firmware somehow just breaks, which I've had happen with RP2040s before, I'll have easy access to reflash it. Now, you might think, why not just mount the microcontroller the other way? Unfortunately, this button here, you won't be able to see it. There are ridges around these buttons, and that kind of gets in the way. It won't sit flat-ish, oriented the other way, unfortunately. So that kind of sucks, but I think having these here makes it kind of cool in its own way, right? Where I can just quickly access these whenever I need to. And these are sitting very low profile, where it's very unlikely that I'll accidentally press these while playing, right? There's no reason for my hand to go over here, and the button press is slightly heavier than these buttons over here. Getting into the wiring, so as I had mentioned, each pin is dedicated to one switch, which makes wiring everything up easy, but it does get kind of messy here, right? I did think of having this mounted elsewhere and just having an extension for this USB port, so I had more space to work with, but I just went this route anyways. It's less parts, less complicated, and so yeah, that's it. This is the ground over here. And if you do take on a project like this yourself, make sure you do solder this to your ground wire, because I believe there's a 5-volt and 3-volt out right beside them, I think. I know the pins on either side are powered, so you want to make sure you don't make that mistake. I did make that temporary mistake, and that was kind of scary. I thought I broke the like burned something out on the RP2040, but it was fine. But you see this solid copper wire here kind of going around. This is a bend, I think. I think this is actually a bend here. But these two are separate parts here. And you keep going, keep going, keep going. There's another bend here. And this is where it kind of gets complicated. It goes straight down to this switch, because this switch needs some loving too. And there's a bridge here, as well as a bridge over here, hidden underneath all these, to connect all these up and give multiple points. So if one solder job is poorly done, right, which is totally possible, just look at this, it's not just going to stop working, right? There's multiple possible points of, I guess, redundancy, I'll say. Things should work, and if they don't, it should be a pretty easy fix. Now, all of the green wires just go to the opposite lead of each switch, and doing this in this manner made things very complicated. I kind of wish with some of these I went out and around or did solid wiring for everything. I think that would have looked really cool, and if I really want to, I can go back and do that, but it seems like a lot of work, and I don't really want to do that. Either way, it's functional, right? That's what matters at the end of the day, and having flexible wiring makes things easier. Plus, this bare copper wire can get kind of difficult to work with, right? You do have to not ground it, shield it in certain areas where there's crossover and things like that. And also just working with it was a lot more difficult than expected. Getting like nice bends was very difficult because you can see this bend isn't perfect. This bend up here was actually pretty solid. And yeah, a lot of these bends aren't as sharp or clean as I would have liked. Maybe I'm just dumb, maybe I don't have the right tools for it, but that's how this ended up happening. Now you might see some heat shrink here, and that's because when soldering this pin, I ended up burning off of some of the shielding, so some added heat shrink there just to make sure nothing bridges where it shouldn't. But yeah, the solder job overall very simple, very easy to do. Moving back to the, I guess, top of the board, right? There isn't really a whole lot to say. These buttons are the concave buttons from junk food arcades, and these buttons come along with them, and these just go over the chalk switches. If you do plan to take on a project like this specifically, you may also want to hot glue these switches in because they do shift around a lot, which is a little disappointing, I'll say, because I thought these would fit in a little more stiffly. Is that a word? Because otherwise they do shift around quite a bit. Of course, the intention of this case is to use with a Snackbox Micro PCB rather than this kind of awkward job, I'll say. These buttons did originally shift around a lot, so I needed to bust out some hot glue. Luckily, the buttons cover up enough where you can't see the hot glue at all, so that's really awesome. Now, I do want to talk about the bottom of the case. So normally, it looks like a sheet of what I'm assuming is aluminum. It's pretty lightweight with a sheet of foam over with micro imprinted on it, which looks really nice. However, this is just, again, a sheet of aluminum. So what I end up doing is applying a layer of masking tape and then applying a layer of white gaff tape. And the masking tape was more so I could remove the gaff tape easily, painlessly, whenever I want to, if that ever needs to happen, because gaff tape is quite strong. So I didn't want to like accidentally like bend this or anything like that in the removal process. And also this helps with damping the sound a little bit, as well as, in my opinion, makes the aesthetics quite a bit better with the white background, being able to see everything a little bit better, being able to see my spaghetti a little bit better. So yeah, I think that's just a nice little touch if you go with something translucent like this. There are options out there that use the same controller and like firmware and all that, and are open source and are much cheaper. The only concern with those, in my opinion, is you have to get certain parts manufactured, which is a bit of a pain. Unless you have your own like 3D printer, you can 3D print a lot of things like these buttons and the cases. So now let's quickly go over what I would redo if I were to redo this. First thing, not use spaghetti wiring. This is also just from an Ethernet cable, and because of how the Ethernet cable is made, these wires don't like to sit straight or anything like that. So not a huge fan of that. For these micro tactile switches, I probably would actually Dremel things flat so I wouldn't have to resort to using such a messy glue job. Yeah, that's about it in terms of the whole like regrets portion. This was a huge learning experience for me, so I don't really regret it, and it's functional. If you are looking at like input delay numbers, GP2040 includes that information all on their website. I'd imagine the actual Snackbox Micro PCB has less latency, but it also includes functionality for PS4 and PS5, which can be quite finicky with these kinds of controllers. That said, I don't own either of those consoles. I mainly play on PC, and I do have a Switch, and this has modes for both. I think it's really cool. You can change the input mode by holding down one of these buttons while plugging it in. Anyways, that's gonna be it for this video here. Thanks so much for watching, guys. I know this was a bit of a different one, and my voice is a little bit gone in this video, so if you're watching up to this point, thanks for sticking around to hear this. I do stream regularly on twitch.tv/nowkeysvt, and I did start a TikTok, so if you want to watch some game clips, game highlights there from stream, those will be there as well. Anyways, again, thanks for watching, guys. I'll catch you guys in the next one.